Good day, grade 11 chemistry students. Today what we're going to do is learn about how to draw Bohr, Rutherford's, and Lewis dot diagrams. To do that, we're going to quickly review what chemistry is, what is the study of matter, and how we classify matter, and then we're going to quickly draw Bohr, Rutherford diagrams. Ready? Here we go. Okay, what is chemistry? Chemistry is the study of matter. Really, it has everything to do with matter, so the composition, structure, properties of matter, and all the changes in everything, that's what we're talking about when we talk about chemistry. We're talking about matter. Matter is anything that has mass and takes up space. It's pretty much everything around us. So the absence of matter would be a vacuum. It doesn't have mass or, take up space. So what is mass? Mass is really the amount of matter, so the amount of protons, electrons, and neutrons that are in there. It's the amount of matter. How do we classify matter? We classify matter into two main groups. So everything that has mass and takes up space can be divided into anything around you can be divided into mixtures, which is mixtures of different types of matter, or pure matter, or pure substances. Now, mixtures can be homogeneous mixtures, which are like salt and water and so on, which are homogeneous mixtures. You can't see the difference between them. It's called one phase. Heterogeneous mixtures, which are known as two phases. And then we have the other group, apart from mixtures, which is pure substances, pure things like water. Well, that's actually made up of many elements, so we call that a compound. When something's made up of just one element, we call that a pure substance or an element. Okay, now what are elements made up? Elements, the smallest element, if you had a bar of gold and you broke it down to the smallest pieces possible, you would break it down into an atom. Okay, that's the smallest bit of an element. So let's talk about atoms. And what is an atom? An atom is the smallest indivisible part of an element. So the smallest bit of a bar of gold is a single atom of gold. We can't get any smaller than that, and it wouldn't be gold anymore. Well, an atom is composed of a very small, dense part, extremely small, called a nucleus. And in that nucleus, you have protons and neutrons. So that nucleus, again, is extremely small, and it has all the mass. So this is really heavy for an atom. All the mass inside your atoms exists inside of that nucleus. Now, there is, in this atom that I just drew here, I drew two positive ones and two kind of dark spheres here, which represent neutrons. So we have two protons, two neutrons. If I have four of these spheres, each weighs 1. This one would weigh 4. Now, where do the electrons exist? Electrons exist way out here, and they have a negative charge, and they're extremely small. So if this atom was a sphere, okay, basically these electrons would rotate around the nucleus and would be extremely small. So the atom is actually mostly empty space. It's actually nothingness, okay, and basically those electrons hang around those protons because negative likes positive things. So this is what our atom is. Basically, if we had two protons, we probably would have two electrons whizzing around very far away from the nucleus where all the protons and neutrons exist. And that's a simple diagram. So they'd be going really rapidly around very quickly at the speed of light around that nucleus. So what made up that atom? Well, it was made up of something called subatomic particles. That means things that make up the atom. That's what subatomic particles means. And the first subatomic particle is called the proton. Now, the second one is the electron, okay? And the third one we'll write down is the neutron. Now, these are the three subatomic particles that make up an atom. This is very important. Write this down. You need to know this. Now, protons have a positive 1 charge, okay? So that means if you have two protons, that means you have a 2+ charge. 3 protons, 3+, and so on. Electrons, they have a negative charge, okay? Neutrons are neutral, so they have no charge. If you have two protons, you'd have a 2+ charge. If you had two electrons, you'd have a 2 negative charge. So if you had two protons and two electrons, they cancel each other out. It's like 2+, 2 negative, no charge. Now, What is the mass of these substances? Well, I said all the mass was located in the nucleus. Now, so let's see how good your memory is. The protons and the neutrons exist in the nucleus. So there they are, protons and neutrons existing in the nucleus. Now, where do the electrons exist? The electrons exist on the outside. They're whizzing around in orbits, we call it. So you can write the location in orbits. Sometimes we refer to these as shells. And they're flying around at the speed of light on the outside. Now, where's all the mass located? Well, the mass is located on the inside. Okay, so what's the mass of one proton? Well, the mass of one proton is, we say, 1 AMU. That stands for atomic mass unit. It doesn't really mean anything yet to you, okay? Now, neutrons weigh 1 AMU as well. So therefore, if you had 2 protons and 2 neutrons, what would I weigh? Well, I would weigh 4 AMU. If each one, a proton and neutron weighs exactly the same, and they just kind of add together. Now, what does an electron weigh? Well, this one is kind of strange. The mass of electron is actually around 0 AMU, which means it's very, very, very light. So comparing the mass of a proton to an electron is like comparing the mass of a car, which is the proton, to an electron, which would be a tiny little bug. It would almost weigh nothing. So when we look at this chart here, again, all matter is made up of atoms broken down to the smallest bits, and all atoms are made up of subatomic particles called protons, electrons, and neutrons. Now, which one is the most important subatomic particle? I always say it's the proton, and take a look at the chart and tell me why. Well, protons are the only ones that have both a charge and a mass, and the protons are actually going to determine what kind of element you are. So this is on the periodic table, which I'll show you in a moment. This is the atomic number. And the atomic number is the amount of protons an element has. If you change the number of protons you have in an element, you actually change the type of element it is. If I change the number of electrons that are in an element, I just change its charge. I don't change what type of element it is. So let me give you an example. If I go from 1 proton to 2 protons, I actually go from a hydrogen element to a helium element, something completely different. If I go from hydrogen with 1 electron to hydrogen with 2 electrons, I'm still a hydrogen atom. I just have a different charge because electrons just contribute charge. Neutrons just contribute mass because they have no charge at all. So if you change the amount of neutrons, you will actually change the mass of the substance, but you won't change what that element is. So let me restate that again. Protons are the atomic number, and it tells you what element it is on the periodic table. So let's look at the periodic table. Here's a picture of the periodic table, and you can see that this number right here, that's the atomic number. It tells you the amount of protons that you have. So hydrogen, this element here, has 1 proton. If we skip over to oxygen right here, oxygen actually has 8 protons. So the small number that's on the periodic table that's bolded, that is the amount of protons, and that is the element that tells you what element it is, okay? So oxygen will always have 8 protons. You can actually vary the amount of electrons and neutrons that exist in that element, but if you change the number of protons, you're going to change the type of element that it is. So if we zoom in on this element here, which is known as scandium, you can see that it has atomic number of 21 and atomic mass, which is a brand new number, which I will explain, which is right beside it. So atomic mass is how much it weighs. So all the numbers beside the atomic number are is the atomic mass, the little tiny number beside it. Okay. Now it actually rounds to 45. So if you have atomic number of 21, you have atomic mass of 45. Let's explain what this means further. So when you look at beryllium here, you can see that it has an atomic number of 4 and atomic mass of 9. Okay, so what do those numbers mean? These numbers are actually going to help us draw Bohr-Rutherfords. It tells us a bit about the atoms. The atomic number tells us the number of protons. The atomic mass will tell us the amount of protons and neutrons. So let me explain. Let's go on further here. So beryllium had these two numbers. It had a 4 and a 9.01 and some other stuff here. Now, first thing that you're going to do is you're just going to round off the atomic mass, just so it's the nearest whole number, okay? So that's something important. If you struggle with these, just round that off. So let's talk about what these numbers mean. So again, the smaller number is the atomic number, a bigger number is the atomic mass. The atomic number, if you recall, tells you the number of protons. So in this case, we know that we have 4 protons. The atomic mass, which tells you how much the atom weighs, remember that the mass comes from 2 subatomic particles. It comes from the protons plus the neutrons. So if protons plus neutrons equal 9, then we have 4 protons plus a certain amount of neutrons equals 9. I'm not going to insult your intelligence here, but we should have 5 neutrons. So far what we know, is that we have 5 neutrons and we have 4 protons. We know a lot about our atom. So what we're going to do is we're going to show our Bohr-Rutherford to show that we have, guess what? We have 4 protons we discovered and 5 neutrons, okay, because that adds together to 9, and this is the atomic number. Now this is going to represent the nucleus, which is extremely small here. Now where are the electrons? So if we're going to draw our Bohr-Rutherford, again, P's mean we have 4 protons. The neutrons, we have 5, and E, I'm going to represent electrons. How many electrons do we have? Well, if we assume that this atom is neutral, if we have 4 pluses, because protons are positive, if it's neutral, that means we have 4 negatives, okay? So what we're going to do first is we're going to draw our Bohr-Rutherford, and we need to know how many electrons and where to put those electrons. Well, when we draw a Bohr-Rutherford, we draw shells, okay? And shells, or orbits, around the nucleus. This is where the electrons exist. Now we're going to draw little spheres here to represent the electrons. Now the first shell, I want you to know where the electrons exist. It can hold 2 electrons. So what we do is we always half fill our shell and then we pair. Now there's 2 electrons. But we recall, to make this a neutral atom, we need 4 electrons. So that means we need a whole nother shell because the first shell holds 2 electrons. Now the next shell that we have is actually going to hold 8 electrons. Now we can't put 8 there because we only have 4 and we place 2 in the first, so that means that we're going to have 2 in the second. Now we do not put both electrons beside each other. What we do is we always half fill before we pair. So here's my 4 electrons. I've got 4 electrons, I got 4 protons, so 4 pluses, and these are my 4 negatives flying around on the outside. It's a neutral atom because it has no charge overall. It's got a mass of 9 because the mass comes from the 4 and the 5 here, or the protons and neutrons here. So the things we got to remember is always half fill before pairing. The first shell holds 2, the second shell, so the first shell holds 2, the second shell, and so on, and onward from that will hold 8 electrons, okay? So 8 electrons are held after that. So let's draw magnesium. When we look at magnesium, we can see that we have 2 numbers. We have a 12 and a 24.31. Let's draw a Bohr-Rutherford for magnesium now. To draw a Bohr-Rutherford, we have to determine the amount of protons, electrons, and neutrons that exist in our atom. So we look here, we see 12. That means I have an atomic number of 12. That means I have 12 protons. We see that we have a mass, so this is my mass, the bigger number, and that is protons plus neutrons. So if that's going to equal 24 because we round it, and we've got 12 protons, that means I need 12 neutrons. Okay? Now, how many electrons am I going to have? Well, the answer is I'm going to have 12 if my atom is neutral. Electrons are negative, protons are positive. So let's put our protons and neutrons in the middle and let's fill out the shells. Okay, so we have 12 protons and we have 12 neutrons. Remember that these guys have all the charge. Electrons have a charge, no mass. Neutrons have no charge and they have a mass. So this weighs 24 right now. Now if we look at this again, the first shell holds 2. Second shells after that hold 8. We half fill before we pair. Okay, so let's place our electrons around here. I always like to start at the top and then I go around at north, east, south, west. Okay, so I'm going to start in my first shell. This is half full. I now can pair. Next, what I'm going to do is I've taken care of 2 electrons. I have 10 more to place. So the first one holds 2, the next one holds 8. And so that means I'm going to have 10 total. That means I'm going to have to place 2 here. So that's 12 electrons that I'm going to place. So I start at the top. I half fill. It's important you do this process. This is where students make mistakes. So listen carefully. Make sure you half fill before you pair. Here we go. All right, so that's 10 electrons. Now I place 1 here. Can I pair it here? I cannot pair it here. No, I cannot, because this next shell holds 8 total. Remember, so it's 2, 8, 8 that it can hold. So I'm going to place this electron right here. And this is what the magnesium Bohr Rutherford looks like. We are going to learn that electrons like to be in pairs. So this electron here and this electron here are the most active electrons. Now, the ones on the inside are not active because they're all paired up and stable. Now, the outermost electrons, the one in this shell right here, they are known as valence electrons. So electrons in the outermost shell are the valence electrons. When we draw a Lewis diagram for magnesium, all we do is we just take the element symbol, Mg, and we put the valence electrons around it just like we saw in our Bohr Rutherford. So we have magnesium with these 2 electrons around it. Now those are the only ones we care about, because the valence electrons, those are the only unpaired ones, and they're the ones that are going to react with things. I want to point out one more interesting thing about magnesium. Magnesium is in the 3rd period down here, which means, and it also has 3 shells. So this number here on the side tells you how many shells it will have. As well, this number up here tells you how many valence electrons it has. Okay, so we might not understand this exactly, but if we take a look at our diagram again, magnesium has 1, 2, 3 shells. It's in the 3rd period, and it has 2 valence electrons, which is represented by the group number at the top. So we'll talk about what this means further tomorrow. Thank you very much. Enjoy your evening.
You're a sky